Today we are going to discuss about how to reduce a general cubic equation with binomial coefficient into one in which second term is one thing, leading coefficient is unity and all other coefficient is integral. To reduce general cubic equation in with binomial coefficient binomial coefficient into one in which second term is one thing and leading coefficient is unity and all other coefficient is integral. All other coefficient is integral. Consider a general cubic equation a naught x cube plus 3a1 x square plus 3a2 x plus a3 equal to 0. Put this equation 1 and alpha, beta, gamma be the roots of 1. Okay. To remove the second term from this equation, we shall diminish the root of 1 by a constant, say h. So write to remove the root, to remove the second term, we shall diminish the root of 1 by a constant, say h. If y is the root of the transform equation, root of the required transform equation, then y is equal to x minus h. This implies x is equal to y plus h. Now substitute x equal to y plus h in the equation 1. We get, therefore 1 becomes a naught y plus h cube 3a1 y plus h square plus 3a2 y plus h plus a cube equal to 0. Okay. Now expand this by using a plus b whole cube formula and a plus b whole square formula, that is this one is this one. Here is in decreasing order and b is in increasing order. So using this formula, we'll expand this. So in next step, you should expand this one. So this is cube 3y square h 3 h square y h. In the second term, it is a1 y square plus 2y h plus h square. Okay. Now write the coefficient of y cube, coefficient of same power together. There are only one y cube term. So this is a naught y cube max. It will be 3a naught h y square. Here it is 3a1 y square. So we will take 3y square common. It will be 3a naught h 3 a naught h plus a1. Okay. Then again write this one 3h square y a naught plus 3a1 2y h plus 3a2 y. So take y common, then 3 common, 3 common, 3 common, 3y common. Within bracket we have this one a naught h square, a naught h square, 2a1 h, 2h a1, then a2 plus a2. Within that bracket I will get this term. Then constant a naught h cube 3a1 h square 3a1 h square 3a2h plus a cube equal to 0. Now we are going to take a naught in place of this, and in here 3 I will take this as a1, 3 I will take this whole as a2y, and this as a3. This is 0, put this equation 2, then 5. This is my a naught x cube. This is a1 x square plus 3 a2 x plus a3. Here where my a naught is equal to a naught. Okay, a1 is this one, a naught h plus a1, a2 is my this one, this one, a naught h square plus 2h a1 plus a2, a3 is this one, a naught h cube plus 3 a1 h square plus 3 a2 h plus a cube. I'm writing all the important equation in the right hand side because my blackboard is very small. So if I rough this, I will have some problem in writing the equations. So I'm keeping a note in the right hand side so that I can easily write this equation. This is my equation 1. Alpha, beta, gamma are roots of 1. Y is equal to x minus h, and second equation is this one, a naught y cube plus 3a1 y square 3a2 y plus a cube is equal to 0. This is the equation 2. Now we are going to find out this values one by one. To remove second term, a1 becomes 0. To remove second term, a naught h plus a1 is equal to 0. If this is equal to 0, then h is minus a1 by a naught. So here h is minus a1 by a naught. A naught is my small a naught. Now find out a1 is this, a naught h plus a1. I am going to find out the value of a2 because if I put h equal to minus a1 by a naught, a1 is 0. Okay. Now what is the value of a2? A naught equal to minus a1 by a naught whole square plus 2 minus a1 by a naught a1 plus a2. Minus square is plus, so this is a1 square, here a naught square, this is a naught. So there will be one single a naught. And here it is plus minus will be minus 2 a1 square by a naught plus a2. This is 1, this is minus 2. So this is minus a1 by a naught plus a2 minus a1 square plus a2 a naught by a naught. Okay. So this is equal to my a naught a2 minus a1 square by a naught. This is equal to h by a naught, where h is my a naught a2 minus a1 square by a naught. So write the value of a2. A2 is my h by a naught, and h is what is h? H is my a naught a2 minus a1 square by a1 square. No, by a2 is h by a naught. Now I am going to find out what is the value of a3. What is a3? Is a naught h cube plus 3 a1 h square plus 3 a2 h plus h. Okay. Now put the value of h. This is a naught minus a1 by a naught cube 3 a1 minus a1 by a naught square plus 3 a2 minus a1 by a naught plus a3. Simplify this one. This is minus a1 cube, a naught cube, 1 a naught cube, cancel out. So this is a square. 3. This is plus, and minus square is plus a1 cube. This is a1 square. Multiplied with a1, a naught square. Minus 3 a1, a2, a naught, a3. Now simplify. On simplification, this is a naught square. This is 2a1 cube, 3 a naught a1 a2, and this is a3 a naught square. This is my z by a naught square. So write this, a3 is equal to z by A naught square, where C is my 2A1 cube minus 3A1 A2. A3 A naught square. Now put this value, therefore 2 becomes A naught y cube plus this term will be 0 as this coefficient is 0. A2 A naught is this one, A1 is 0, A2 will be this one. Here A naught is my small a naught, then y plus A3. A3 is my g by A naught square. And this is equal to 0. This is 3. Write the equation 3. A naught y cube plus h y a naught. This is 3. There will be 3. This 3 will come. And here, this will be 0. This 3 will come. Here it is okay. Put this equation 3. To make this equation free of fraction, we will take the transformation z is equal to a naught y. Therefore, transform equation become transform. To make this free of integer, we will multiply the root of this equation by a naught. Therefore, required transform equation becomes z cube 3az plus z equal to 0. This is equation 4. 4. Okay? Where z is my a naught. What is what? Y is x minus h. Okay? Z naught y, that is a naught x minus h. And what is h? H is x. H is minus plus a1 by a naught. Okay? This is equal to a naught x plus a1. Okay? Since alpha, beta, gamma are roots of 1, we get a naught alpha plus a1, a naught beta plus a2, a naught gamma plus a1. Here it is a1. Replace x by alpha, beta, gamma. Alpha, beta, gamma as the root of 4. Okay. Also, alpha, beta, gamma is the root of equation 1. By relations between roots and coefficient, we have, since alpha, beta, gamma are roots of 1, therefore by relation between roots and coefficient, we have what we have? We have alpha plus beta plus gamma is equal to minus 3a1 by a naught. This implies a1 by a 0 equal to minus alpha plus beta gamma by 3. Okay. Now, first you should write this equation 4 in the right hand side so that you can use this one later on. This is 4 and z is my a naught y. Root of this will be a naught alpha plus f1 a naught beta plus f1 a naught gamma plus f1 roots of 4. Okay. Therefore a naught alpha plus f1 can also be written as a naught alpha plus f1 by a2. Now substitute the value of a1 by a naught. This is a1 by a naught, okay, not a2, because we are taking a naught common. Then this alpha plus a1 by a naught, if we expand this, we will get this big. So this is minus alpha plus beta plus gamma by 3. Based on simplification, we will get this one 3 alpha minus alpha, that is 2 alpha. This is minus beta minus gamma by 3. Okay, similarly a naught beta plus a1 equal to a naught here 2 beta minus gamma minus alpha by 3. Looking into this, we can write this a naught gamma a1 equal to a naught 2 gamma minus alpha minus beta by 3. Okay, these are the root of the equation 4. For is the required equation whose leading coefficient is unity and all other coefficient are integer. Okay, free of fraction. Next, if we substitute, if we put z equal to a naught y, that is a naught x minus h in 4, okay, 4, then on simplification and simplify we will get 1 multiplied by a naught square. Okay, that is a naught square fx. That's true. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.